Hello, everyone. Hi, Abdul, you want to get started?
Yes, perfect. Hello, everyone. Hope everything is right on your side. My name is Abdul Basit, and my colleague name is Mr. Fabian, and we are here to present you our solutions. We are Bester Business located in Barcelona, Spain. We are in the connectivity world since 2016, and today the presentation will be more or less related to the software solution that we are presenting. And Mr. Fabian will do the presentation. And for example, in the meantime, if you have any questions, you can also put in chat and I will answer all to your questions. And if some questions are unanswered, we will surely get in contact with you. So, yeah.
Excellent. All right. Thank you, Abdul, very much. Hello, everyone. Welcome. So today's webcast is going to be short. It's going to be about how to collect data from controllers. In this case, I'm going to be doing some examples about collecting data from devices using OPC, OPC UA, and Modbus, and sending this data in real time to Amazon Web Services. Okay. So yeah, there you go. So first of all, we're going to be, this is the index, very quick, about who we are. Probably many of you already know our company or some of our products. So I'm going to give a very quick introduction to our company, talking about MQTT protocol, how MQTT works. Probably if you're here today, it's because you're already working with this protocol, or you want to get started working with this protocol, or probably one of your vendors is asking you to move the data using MQTT. So we're going to see how to do that using our IoT Gateway named vNode. On the other side, we're going to see how to link the OT data with IT, all right, and how to move the data to the cloud. In this case, as an example, we're going to be moving the data to Amazon Web Services, all right? So I have an account. I already configured an object. I'm going to show you about that in a moment. What else? And then, of course, I'm going to be doing a quick demo about collecting data with vNode, collecting data from a couple of devices, actually 3 different devices, and pushing all this data to Amazon Web Services and as a simulation or actually real data movement, right? So these are our brands. You probably know one or many of them. As I was explaining, these are our brands. Matricon software to connect to the control devices, vNode as an IoT connectivity gateway. Advice is our SCADA from the company Bachmann. We are the distributors for this SCADA HTML5 SCADA software. And VITC is our division in the company for specialized training. This is a division in our company where we give specialized training, 3 days hands-on training, specialized in different technologies. For example, in IoT protocols, in industrial protocols, in OPC, OPC UA, in cybersecurity, in SCADA designing. So we have several trainings that we give. We perform in different countries, and of course, especially for our customers on site. So enough about this. So let's move on. So what is MQTT protocol? So MQTT protocol is a way of moving data. It's a protocol, of course, to move data from point A to point B, which has been invented many years ago. But it has become very popular through this new way or wave called the Internet of Things, or the industrial Internet of Things. Why is this? Because MQTT is a very easy way to move data from one side to another, especially for very small devices with very low power. Okay, so how does MQTT work? So on one side, you have a software or a firmware, actually a hardware, whatever it is, with a firmware inside, or any kind of software. It doesn't matter. Could be software in a computer or a firmware in an embedded device, in whatever it is. So this software or firmware can work both as a publisher or as a subscriber. So this firmware or software gets data from whatever it is and then pushes this data to a broker. Okay, so in this technology, we have three different actors. Okay, so we have the publishers, we have the subscribers, and we have the brokers. Well, actually one broker. So of course, the publisher publishes, sends the data to the broker. The subscriber, of course, subscribes from the broker. The broker holds all the data from everyone, from all the publishers in a unique single place. The broker is a software, is another software. So this broker, this software, broker can be anywhere, can be running in your computer, can be running in your network, can be running in the cloud, can be running in your private cloud, or of course can be running in a public cloud. For example, all these public clouds, typically starting with Amazon Web Services or Azure or Google or many other clouds, public clouds that you can subscribe to, or you can you can hire as your cloud application for creating your dashboards or holding or analyzing data. Most of these cloud applications, they have their own broker. So you as a publisher or you as a subscriber, you can publish or subscribe from this broker in the cloud. But the broker can be anywhere. It's just a software, okay? So of course, there are brokers which they're free. Some brokers are not free. The easier, or the broker, for example, I use a lot in order to run tests, is a broker called Mosquito. Mosquito is a MQTT broker. You can just download from, you can search in Google, download Mosquito, you can test Mosquito and run it for free. Of course, there are brokers with more and less capabilities and features. Mosquito is a very good starting point in order to play with the MQTT technology. All right, so each client will be connected to this broker. Of course, this connection can be secure or not secure. So if it is secure, it's going to be MQTT-S. It's going to need an exchange of certificates, and then all the clients are going to be connected to this broker. Okay, this broker, of course, you can create many different activities. For example, validate or not users, filter the messages, and of course, when as a publisher you publish information, you publish your messages to the broker, they need a topic. A topic is like the title of what you are going to send to this broker. So then the subscriber are going to be subscribing to a specific title, a specific topic, and every time that topic has a new message, all the subscribers are going to get the message from the broker. Okay, so of course, this is a very simplified way to describe the MQTT, how MQTT works, right? So why to move the data from OT to IT? There are many reasons for doing this, but of course, if you're hearing this webcast, is because you are working with controllers, with plant controllers, industrial controllers. Here we have some examples: Siemens PLCs, devices speaking Modbus, Rockwell PLCs, OPC servers, OPC-DA, OPC-UA, ADB devices, DMP3, speaking RTUs. So these are just some examples about different protocols we can have, or different devices we can have in the industry, and we want to move the data from these devices to the cloud. There are many reasons for this, but for example, many of these clouds, these are just some examples. Of course, we can work with Dynamics or Maximo for maintenance, or Google Cloud or Amazon Web Services, etc. All these applications in the cloud are, of course, doing some specific activity in the cloud with the data coming from your devices or from your data coming from the shop floor. Okay, so we're going to be showing how to move this data from one side to another, from your local network to the cloud, okay? From your secure devices to these applications in the cloud. All right, so every device of course, in the OT network, in a control network, they speak different languages. So you need on one side or an OPC server or an IoT gateway, which has the functionality to connect to these specific protocols. And this is exactly what we do, what vNode or Metrogon software is doing in this case. So we are going to be using vNode in this case to move the data securely from one network to another. In this case, we're going to be moving the data from my network in my office in a secure network, actually. The data is going to be coming from simulators, but we're going to be really moving data from some simulators running in a virtual machine in my office to, in this case, to Amazon Web Services, okay, with complete security, okay, and encryption. So what is vNode and what is Industrial IoT Gateway? Okay, so here, if you can see, this graphic represents different levels or different networks inside, of course, a big industry or a big company. So we have a control network separated through a firewall from the OT network where the PLCs and the RTUs and the DCSs are living. Then we have a level 3 with OT applications, typically maintenance applications, databases, mesh systems, historians, SCADAs, and so on and so on. Then we're going to be moving through a DMZ in order to isolate the control networks from the IT. And then in IT, we're going to have a business layer with all the business intelligence, ERPs, SAP, and so on applications. And then from there to the cloud, okay, from 2 cloud applications. So of course, these all these levels are, of course, not mandatory at all. Some companies, they only have 1 layer, or maybe 2, or maybe 3, or maybe all of them, depending on the company and how big is the company and what are the needs of splitting the networks in different VLANs or in different networks through firewalls, protected by firewalls. So what we are using here is vNode as an IoT gateway in order to collect the data from the devices, from the control devices or SCADAs or OPC servers, RTUs, DCSs in that specific network, do some data aggregation, do some logic, do some math between all these tags, and move the data to a vNode in the next layer. This vNode in the next layer will be collecting the data from the other vNodes, collecting all the data. Again, if you want, you can do more logic, more data aggregation. All this data is going to be available for all the applications in that specific layer using OPC UA or Modbus or DMP3. There are many options inside vNode in order to give data coming from other vNodes, to give the data to these applications to consume the data. From this vNode through the DMZ, we can send the data securely from the most secure network to the less secure network, keeping the firewalls completely closed, okay? So we're doing a reverse connection from the most secure network to the less secure network. So this vNode, again, is going to collect all the data coming from all the different vNodes in other layers. Is going to, again, to give the data to the applications in that specific network. And of course, we'll be pushing the data, if we want, to the applications in the cloud. Okay, again, this is just an example. We don't need to have all these layers. We don't need to have all these vNodes, one connected to another. We can have just one vNode in one of these networks, and that's it. We can have 2 or 3 or 4, or we can have more vNodes dispersed in different networks, in different control networks, and then pushing the data and doing aggregation until we have a unique central vNode, which is the one that is going to be feeding data to the applications on top. Okay, so this is what we're going to be doing today. So there are a couple of ways how to send data to Amazon Web Services. Of course, for example, in Amazon Web Services, there is an OPC UA client also in the cloud that is available to connect to your devices. Or of course, if you use an OPC UA client in the cloud, connecting to your devices in your office, so of course, you need to open the firewall in your network. And this is normally something you don't want to do, because if you are going to be connecting a client in the cloud and a server, an OPC server in your network, of course, in OPC, the connection goes from client to server. So you need to open at least one port in your network. This is normally something you don't want to do. So another way would be, of course, using MQTT, and this is what we're going to be using today. So we're going to have a vNode running in a virtual machine here in my office. I'm going to share with you this virtual machine in a second. In this virtual machine, where I have Windows right now, but of course I have Windows 10. Of course, we can have Windows, we can have Linux as well. It doesn't matter. vNode works both in Windows and in Linux. So we're going to have this vNode connecting or collecting data from an OPC DA server. We're going to be collecting from a Modbus simulator, which is, of course, simulating being connected to any kind of PLC speaking Modbus protocol. And we're also going to be connected to an OPC UA server. So we're going to have three data sources. So inside this vNode, apart from these three functionalities, we're going to create with you a new functionality, which is going to be the vNode MQTT Client module. So inside vNode, we have more than 45 different functionalities. We call these functionalities modules. And all these modules, they can be modules to collect the data, to work with the data, like creating logic, math, etc., or histories in the data, and then modules to send the data out. So in this vNode, we're going to have a module which is going to be an OPC DA client, a module which is a Modbus client, a module which is an OPC UA client, and we're going to be creating a module which is an MQTT client module. So we're going to create this module MQTT, and we're going to be connecting to Amazon Web Services, and we're going to be showing how to do this, how to connect to Amazon, and then how we're going to see the data arriving to Amazon. On the other side, then we're also going to be writing data in Amazon, and we're going to see how we get the data back to our vNode. vNode is going to be writing the data in our simulator, Modbus simulator. We're going to see how we write a value in Amazon. And this number is going to be changing in our Modbus device. All right, then. So let me share with you. My virtual machine here. This is my screen number 2. Is this one? There you go. Perfect. Okay, so as you can see, this is a virtual machine. Okay, so it's a little slow, but it doesn't matter. So I'm going to start my Modbus device. So this is just a Modbus simulator. So I'm getting started my Modbus simulator over here. Give me a second. There we go. So this is just Modbus simulator. Data is supposed to be, yeah, it's changing between around 2 seconds. Okay, so I'm going to be writing something in this simulator. So it is working and it's giving to our Modbus client. It's going to be giving our tags. Perfect. All right, so I don't need to have this here. So here I have, let me open this. So here we have, there we go. All right, so we have vNode here. So vNode, when you install vNode, vNode, the way to configure vNode runs as a Windows service, and the way to work with vNode is through a browser, or the way to configure vNode is through a browser, okay, a web browser. So right now I'm in localhost, I'm using Edge from Microsoft, and I'm connecting using this port, okay? So when you connect for the first time, user is admin, and the password is vNode, all in lowercase. then of course you can create as many users and change the passwords and everything. So inside vNode, this is the configuration of vNode. Let me show you. So as I explained, we're going to be using 3 modules. I already have these modules running because I don't want to waste time with this part about collecting the data. I want to use my time showing how to connect to Amazon Web Services. All right. So there we go. So I have a module, which is a Modbus client, a DA client, and a UA client. Okay. So let me show you very, very quick the configuration for these 3 modules. So I have my Modbus client. Modbus client is this one. I call this C1, is connected to localhost using TCP. Okay, and connected to the port 502 because my device, this one, is listening the port 502. All right, so this device, which I'm using as a simulator, is listening the port 502. So we are connected using this channel and this device. So I have my channel 1 and my device slave ID number 1. All right, then I have my OPC DA client. So I can create more connections if I want. In this case, I only have 1. In this case, I'm connected to this. These are an OPC DA client. I'm connected to an OPC server in this computer, which is another computer in my network. And this is the ProgID simulator for Matrix on OPC. And I also have an OPC UA module. And inside, again, I can create as many connections as I want. In this case, I have my connection number 1. I call this C1, and this is my endpoint. All right, so I'm connected to, again, this computer in my network, and this is the port. All right, so this is my endpoint. Once I have my 3 connections, I can create tags. I already have my tags created in 3 different folders. So I have in Modbus tag 1 and tag 2. Let me show you. This is a tag which is a number, is using my module called Modbus and my channel C1D1, and I'm reading this Modbus address, okay, the 40,001, and this is an integer 16 reading every second, okay? So I have tag 1 and I have tag 2. Here I have my OPC DA tags, which I'm reading from my OPC DA client. The name of the module is OPC DA. My connection is called C1. The name of the tag is random.int1. It's just a random tag which is coming from a simulator, an OPC DA simulator from Metricon. I am reading data every second, right? I have int1 and int2. Here, 2 different tags. And OPC UA, again, I'm connected using to my module, which is an OPC UA client. Okay, the module is OPC UA. The connection is C1. This is the node ID. Okay, I'm reading every second. I have counter 1 and counter 2. So I have my 6 tags, 2 coming from Modbus, 2 coming from OPC DA, 2 coming from OPC UA. If I go to real time here, I can see my tags changing, right? So I can see my tags changing. In here, of course, the tag 1 and tag 2 tags, they must match with my tags coming from my Modbus simulator. So if I open my Modbus simulator, computers are a little slow right now. Let me see if this is doing something for me. So where is my Modbus simulator? Come on. All right. Well, it doesn't matter actually because the Modbus simulator is not showing, but it's actually giving me data. I will kill it and open it again. What is happening with my simulator? All right. Anyway, well, all right, don't worry. So I'm going to open this again. It doesn't matter. So there we go. All right. And all right. Perfect. Okay, then, so because I restarted the Modbus simulator, it's going to take a moment for the Modbus client is trying to reconnect over and over and over again until, well, it takes probably 30 seconds. It tries, I think, 3 times and then waits for 1 minute and tries again 3 times. So we're going to get connected in a second. So here, we're going to see this connection in here in the moment we get connected with the Modbus client. Okay, on the other side, let me show you what I did in, there you go. We're connected, there you go. So I have my 10 here. So as I was explaining, if I write something in my Modbus simulator, immediately I have it in vNode. Okay, so there you go. I write the 0 here, immediately I have it here. All right, so on the other side, in Amazon, this is my Amazon computer. Well, it's again a browser. This is my Amazon account. So I'm connected to this service called AWS IoT Core, okay? So in here, so I created a thing in here. So you need to get started by connecting to one device. And then I created a thing in here. This is complex, so you need to take some time to understand how it works. But mainly, I created a thing. I call broker AWS. Inside here, I have my certificates. I have my certificate ID. All right, and here I have a policy. You need to have your security policy. I have a policy called publish vNode. And in my policy, I have this policy number 6, which is giving me complete permission to receive data from my thing or my connected devices, all right? So if I go to settings in here, I can see my endpoint, which is part of the most, probably the most important part, which is here, my endpoint. This is the endpoint I'm going to configure in vNode in order to send the data to this broker in Amazon Web Services. Then when the data is in Amazon Web Services, of course, you can send it to a database. You can play with the data inside all the services inside Amazon Web Services, which, of course, I don't want to get in because it's really, really extended. But the idea is to send here is to show how to send the data to Amazon Web Services. All right. So this is my endpoint. Where in the moment you create your policy, you get your certificates. I have my certificates right here in a folder in this computer. So these are the certificates we're going to be using to configure my client, my MQTT client inside vNode. Okay. Here I have my MQTT test client. And we're going to be using this test client to see the data coming from vNode to Amazon. All right. So let me go back to here to vNode. Okay, so we have the data moving. So let's configure the new module, which is going to be the MQTT client. So if I go to config, modules, here I can create a new module. I'm going to call this MQTT, right? In here is where I can select from all the features inside vNode. As I was explaining, vNode has today more than 45 different functionalities, all right? From all these functionalities, I'm going to be choosing MQTT client. So this module called MQTT is going to be an MQTT client. All right, so I have my module. All right, so for the first time, I need to save the components in order to create the configuration file. There we go. Okay, so in here, we're going to create the channels and the connections. So what do we do? Number one, we come here and we create a new connection. So I'm going to be calling this AWS. There we go. All right, so here we have all our fields to fill in. So we're going to enable the MQTT connection. Yes, the version, we have several options here. Okay, right now we're going to be using MQTT version 3. The destination broker, we have different options here. In this case, vNode comes ready with the connection. with the configuration to connect to Azure, to Amazon Web Services, and to Google IoT Core. So in this case, of course, if you want to connect to Mosquito or any other broker from any other vendor, you can totally do by selecting custom. Okay, in this case, I'm going to select Amazon Web Services, right? So I need to introduce my certificates. As I was explaining, I already have my certificates here in a folder in this virtual machine. I download this in the moment I created the policy inside my account in Amazon, in the AWS. Okay, so let me select my 3 certificates. So here inside my folder, I have my certificate, this one, right, and open. It's uploading, and there we go. Let me select the private key. Again, going to same folder, getting the private key, which is actually virtual machine is really slow. All right, private key, this one. All right, and now my CA certificate. There we go. So again, same folder. I can upload the CA certificate. All these files, I have downloaded them from my account in AWS in the moment I create the policy in the IoT Core. Okay, so I select the CA here, certificate. All right, I'm ready. So I'm ready to go. What else? So I need to here introduce my broker URL. I just show you in the website where to collect this. I copy this in just a text file, copying from here, pasting in here. All right, there we go. So I have my broker URL. What else? Client ID. I can select any client ID. So I'm going to select here like webcast. Client ID, it's just a name in order to introduce myself to the broker. So all the clients, of course, they have to be different. So last will and testament, I don't want to configure any of these right now. So now I'm going to configure agents. All right, so as I explained, we can be publishers also or subscribers or both. So right now I'm going to be a publisher. I want to send my data to AWS. I'm going to be calling this P1, like publisher 1. So publish interval, how often I want to send the data. I want to send it, let's say, every 5 seconds. So of course, in a real project, you're not going to be sending data so often, but right now, in order to see this moving fast, I'm going to be sending the data every 5 seconds. So I can select here the mode, event, or snapshot. I want to, so what do we want to do, or what data we want to upload to AWS? Everything that is happening in all the data I'm collecting in vNode, or just the data in the moment I'm uploading the data, okay, every 5 seconds. So I have 2 options. So I can collect, and then every 5 seconds push all this data to AWS, and then again collect changes, data, and again pushing it to Amazon. That would be uploading events. Or snapshot would be just I will read the data every 5 seconds, and the tags, the value of the tags in that specific moment, only those values are going to be uploaded to AWS. So we have these 2 options. In this case, I'm going to select snapshot. So just the values every 5 seconds are going to be uploaded to AWS. So the topic, let's say I'm going to be saying, okay, these tags, let's say, are coming from my plant, and they're coming from my area 1. Okay, so we're going to be uploading data from area 1, 2, and 3. These are going to be the tags coming from OPCDA, OPCUA, and Modbus. All right, so the topic is ready. QS, I'm going to select 0. Message options in here. This is okay. So on forward is going to be yes. That means that if for any reason we lose the connection between vNode and AWS, so vNode is going to keep this data in the hard drive and is going to push it to Amazon afterwards when the connection is back. So we are not going to be losing any values. So message format, we can select from many options. So this is fine. The data format, I want to put it in ISO so we can read the date format. Compression none, encoding UTF-8, that's fine. And I'm going to select tag filters. That means we're going to select what tags we want to send to AWS under this topic. So I'm going to call this filter F1. And inside, I can select what tags or groups I want to be included. I want to send included in this topic. So let's say the Modbus ones. Okay, and select group. And that's it. So we're going to be pushing all the tags inside Modbus, right now only 2 tags, inside the Modbus folder every 5 seconds. Okay, and save. And yes. All right, so let me create all the other publishers. So instead of, I have my publisher 1 with my filter 1. So instead of creating 2 other publishers, because I want to have other topics, so I'm going to go to P1, right click, and duplicate. So I'm going to create here my P2, and here inside, I'm going to change area 1 by area 2, and in my filter, I'm going to change Modbus by let's say OPC here. So all my tags inside the folder OPC are going to be uploaded under the topic area 2. And again, duplicate. I'm going to create P3 here. All right. And all my, so let me change again, topic 3, area 3, and my tags are going to be here coming from OPC UA. Okay, so I have my area 1 is Modbus, area 2 topic is going to be OPC-DA, and OPC UA is going to be /plant/area 3. Okay, so if I did everything correctly, so everything should be uploaded to Amazon Web Services. So let's see if we are really sending data or not, or what are we doing. So if I go to here to my website, I have my MQTT test client, so I have to subscribe to a topic. So this is just a testing client, right? So here I'm going to put /plant/area 1. So unsubscribe. So if we are correct and everything is going more or less okay, we should have all the values being uploaded. And here we have. So as you remember, plant area 1 are the tags from Modbus. So check the timestamp here. We should see that every 5 seconds, we have new values being uploaded to AWS, okay? So I get all the packages. Every 5 seconds, I get tag 1 and tag 2. And again, here, tag 1 and tag 2, and I get all these packages coming to my AWS broker, okay? Check the timestamp. Every 5 seconds, I have a new package with new values coming, okay, from my vNode to AWS. All right, so if I subscribe to area 2, for example, subscribe here, there we go. So again, if you remember area 2, I have my OPC, my tags inside my OPC folder. So again, same situation, of course, other values, other tags. So every 5 seconds, I have my 2 tags, of course, different values. Every 5 seconds, I have a new TCP package bringing new values to the cloud. Okay, and again, if I have my area 3, I'm going to get my tags coming from OPC UA. There we go, OPC UA, again, every 5 seconds. So all these three publishers are completely individual. Okay, so I can, of course, I can get all my tags inside the same publisher, no problem. This is just a way to show how I can publish different data at the same time with different, of course, if I can use different topics, different frequency, different formats, etc., etc. So, so I have my area 3 OPC UA values, and of course, there is something I can do, which is I can subscribe to /pound, which is going to subscribe to the three topics at the same time. So if you see right now in the same group, at the same time, in the same subscription, I have data from area 1, area 2, and area 3 in the same subscription. All right, then. So I am really pushing the data to AWS, okay, from my vNode. Let me show you this. I'm going to move this to one side, okay, and this to the other side. There we go. Okay, so if I go in here to my simulator and I just stop this from change, here, no animation. Right, there we go. Okay, then, all right. So if I go here, area 1 was, of course, my tags coming from vNode. So remember that MQTT only is moving the data when the values are really changing. So if there are no changes, no messages going through the broker, okay, going to the broker. So if I go here and I write a 1 in here, we should see this one here in, there we go, in Amazon. Okay, remember that we're pushing the data every 5 seconds. Okay, excellent. So, okay, so what I'm going to 44 here is going to be a 44 here in Amazon 5 seconds later. Okay, so I'm going to do the opposite right now. So what I'm going to do, I'm going to write from the broker to vNode, and it's going to end up in Modbus. So what I'm going to do first, I'm going to create a new empty tag here. I'm going to go to my folders, right-click, new group. I'm going to create MQTT folder, and inside I'm going to just create a new tag. Okay, it's going to be called test. Okay, and this test is going to be a number, could be a string or could be a Boolean, anything. So, and it's going to be read and write. Okay, read and write. There we go. So just save it, and that's it. So every time I want to write into this tag, the name of the path of this tag is /MQTT/test. Okay, if I go here and I go to see only MQTT, is empty for the moment. So I want to go now to my broker again in here, and I want to write. So I can publish to a topic. Okay, I can publish to a topic. So first of all, I need to create a subscriber in my MQTT module, because all of these are just publishers. So I want to collect the data. I want to be subscribing to a topic in order to collect the data from the broker to vNode. So I'm going to go here, right-click, a new subscriber, this one. I'm going to be calling this S1. All right. So this subscriber, the top is going to be /write. Okay. All right. /write. And the encoding is going to be UTF-8, so we can read the data. No compression. Serialization is a JSON. All right. And the data parser, I'm going to just create a custom data parser. Okay. And so we can have anything coming to our vNode, and then we can parse all this message into tag vNode tags. All right. So inside the parser, we already have this JavaScript script, which is actually very, very simple. It looks complicated, but it's not. Everything which is in green is commented. So this is a commented script in JavaScript, very simple, which is just collecting the data, going through all the content of the message and writing inside my tags in vNode. So we're not going to be using this script because I created something really, really simple, which is just this. So in order to make it really, really easy, so I'm going to just delete all this and paste. Actually, this is just sending to the logger the message, and I'm just pushing my input, the message coming from AWS. I'm going to just push this to vNode. So the output is actually the input. That's it. And save it, and that's it. All right. So so vNode is going to be connecting to AWS. It's going to be subscribed to this topic, and everything that is coming is going to be sent to the tags in my tag in vNode. Which tag? Well, the tag I have to say in the message. So what do I want to do? I want now to write something from AWS. I want to write exactly this. So this is the tag and the value. So let me come back to AWS right here. So the topic to publish, right? I'm going to publish. So this is going to be /write. And the message is going to be the tag I want to write and a value, and that's it. So if I go here to real time, and we go to MQTT, let me try to put this in the left side of the screen. Here, there we go. All right. So if I publish this, if I'm doing this more or less okay, is going to go, this 14 should be going to /MQTT/write. No, sorry. I created /MQTT/write. I call it test, not write. So this is going to be here, test, not write. There you go. There we go. All right. So everything I write here, this is just, of course, a very, very simple example. But here we are showing how a publisher is going to be making changes in AWS, okay, in the broker, and we're in vNode, we're collecting the data from the cloud, and we are writing this data back inside vNode, okay? There we go. So what are we going to do now? I'm going to do it a little more complicated. I'm going to write inside Modbus. How do I do this? Because the name of my Modbus tag is this one. It's going to be /Modbus/tag1. So if I change this to /Modbus/tag1, there we go. Okay, I'm going to write any new number. Okay, so this is going to be coming here. And because this tag is attached to our PLC or our simulator, this number should go to vNode. vNode is going to write it using Modbus in our device. There we go. So I'm writing something, I'm publishing something in Amazon Web Services in the broker. The broker, so because we are subscribed to the broker with vNode, vNode is collecting this number and vNode is pushing this to the real control device. Excellent. Okay, guys, this is what I wanted to show to you, okay? How to make a quick configuration in the IoT core in AWS, how to connect to AWS using an IoT gateway, collecting data from real OPC servers, because the OPC servers are real, the data is simulated, but the OPC servers are real, and this Modbus simulator is also giving us real Modbus values from a simulator, of course, and we're sending data to AWS and bringing the data back to our devices and writing in real devices. All right, all this without opening any firewall or anything with complete security, because I'm not opening any firewall in my network, okay, my secure network. Okay, so let me go back to my here. Let me go back to my other screen. All right, here we go. All right, so you can totally download vNode, okay, from vnodeautomation.com and test yourself. You don't need a production license to test vNode. Everything, all the features in vNode can be tested for 2 hours, and after 2 hours, you just press the restart button and you get 2 hours again and again and again. So you can test everything I just did. You can test by yourself for free, actually. You can download the software, the installer for Linux or for Windows. It works in any version of Windows, and in Ubuntu, in Debian, and in CentOS. You can also, it runs in a Raspberry Pi, runs in virtual machines, and runs in Dockers. You can download vNode, and you can totally test by yourself, okay? Of course, I'm going to share with you this video, so you can also, of course, you can follow my steps to make it easy, all right? So what else? So these are our contact details. Let me go back a little bit to the chat to see, I don't know, Abdul, if there are
yes, there is
questions, something you want to cover.
Yes, Fabian, there is a very good question asked by Mr. Ras that why we need a secure IoT gateway when we can directly, some PLCs are offering like MQTT Client and some have. So why not we directly connect, and instead of that, we use vNode? Can you please answer?
Thank you. It's a very good question. Actually, there are many questions, many answers, or many reasons, actually, many reasons for that. Reason number one is if you're going to start sending PLC by PLC or device by device from your plant, everything going to AWS, you are going to need to handle maybe dozens or hundreds of connections in AWS, and that's complete chaos. That's number one. Number two, the payload inside the device, your PLC or whatever, usually, not always, usually is not, you cannot customize the payload in your device, in these embedded devices. Sometimes you can, usually you can't. That means that if you have 2 devices from 2 different vendors, you're going to be sending to Amazon Web Services or your cloud software, whatever it is, your cloud platforms, different payloads, I mean, different messages with different formats. So this is something you don't want to need. You don't want to have having a cloud platform with many different incoming connections, and all of them with different payloads, with different formats inside the messages. So that's the second reason. Third reason, probably what vNode gives you the option is to collect all data and give a common structure to your data. So you can collect the data from one PLC, another device, another protocol, read from files, read from databases. And after you read everything, you can create logic. You can, for example, make an average of your data or create any kind of logic or calculations. And then you can just send to AWS the results of all these logic and all these math, all the averages or all the results of your calculations. So this saves a lot of money. Something you don't want to do is to move data every second to these cloud applications. It's too expensive. So, and also probably you don't need to send the data to these cloud applications every second. But what you do want to have is you do want to collect the data from your control devices every second, send everything to your IoT gateway, and then using this real-time data, let's say every second, make all your calculations, average every 10 seconds, average every minute, the max value every hour, or put the addition of 2 or 3 or 4 tags or any kind of crazy calculation. And the result of that, that is what you want to send to AWS with just one connection. And then you can, in just one application, you can manage all your topics, all your connections, and all your data. So these connections to cloud platforms, they become crazy very, very, very fast. And they become very expensive very, very fast because it's very easy to send too much data. So these IoT gateways gives you the option about managing your data before sending this to this cloud platform. On the other side, many of these cloud platforms, not AWS, but many others, most cloud platforms, I can say, they need the payload, I mean, the format of the data inside the MQTT messages to be a very specific one. You cannot send whatever you want. And this happened to us many times. Actually, many of our customers, they come to vNode, they start trying to connect their own devices to the different cloud platforms in order to make all kind of course, functionalities in the cloud. And when they can make the connection, but then they send a message that the cloud platform cannot understand. And when they see the documentation or they speak with support from this platform, they say, no, you cannot send whatever you want. You have to send the data in this specific format. So a JSON or a JSON of JSONs or an array of JSONs, whatever it is. So in vNode, you can create your payload. You can create the format. So, and you can create the specific format your cloud vendor needs. And this is something that probably, or sometimes you cannot do with any embedded device, even if it can connect to an MQTT broker.
Perfect. And one more question. Fabian,
yes.
One more question.
So sorry for being too extended.
Thank you for your comprehensive answer. The next question we got is from vNode compatibility with different hardwares. Which type of hardwares they need? Do the final customer need a local server, or it can be run on the cloud, or what are the requirements?
So actually, vNode can be running in any Windows or Linux. It can be running in 32 bits, 64 bits, or ARM like a Raspberry Pi. It can also run in Docker. It can also run in any virtual machine from Microsoft, of course, VMware, and so on. So, or Oracle, what is the name of the Oracle virtual machine? I don't remember right now. Anyway, it can be running in any of these platforms. You can have it running in your network. You can have it running in the cloud. It doesn't matter. So one vNode can connect to another vNode to move the data from vNode to vNode. So what a normal, a usual architecture is having a vNode in your control network, collecting the data from your control devices, pushing the data to another vNode in real time, and connecting from, again, with total security, with reverse connection from the inside to the outside through the firewall without opening incoming ports in the control firewall. And then you get the real-time values in another vNode in your IT network. And then in your IT network, you connect to your cloud platform using MQTT. Yes. So this is a common architecture, of course, because you can connect many vNodes to many vNodes, and all of them can collect the data, all of them can create calculations, and all of them can push the data out to any application using OPC UA or Modbus or DMP3 or REST, or of course, sending the data to the cloud. The choices you have to create architectures are actually infinite, are many different architectures.
And what is this capability store and forward? Can you please explain a little?
Yes, totally. So we have two levels of store and forward. So let's imagine we have a vNode collecting the data in the control network. Then it's pushing the data from the inside to the outside to another vNode in the IT network. And this vNode in the IT network using MQTT is pushing the data to the cloud. So if the connection gets lost for any reason between one vNode and the other, so the vNode in the control network, which is collecting the real-time data from the control systems, will start storing the data in the hard drive. So it has no limit of data because it's storing in the hard drive. So it depends on the how big is the hard drive, but don't worry, the size of the data is very, very, very small. So with a typical hard drive, you can keep years of data. So when this connection between vNode and vNode gets reconnected, so all the data collected in the vNode in control with the same timestamp and in the same order is going to be sent to the vNode in IT. And the vNode in IT, again, in the same order with the same timestamp, with the original timestamp, is going to be sent this data to the cloud. Now, this is one store and forward. There is another store and forward, which is what is happening if the vNode from IT, which is connected with using MQTT to the cloud, what if this connection gets lost? Because that can happen. Let's imagine you just lose internet in your office for like 1 hour. What happens? So I'm losing the data. No, you're not losing anything. So that vNode will keep collecting data from the control networks, from the real-time data, and will keep the data in the hard drive. And once the connection to the cloud gets reestablished, we'll send the data again to the cloud in the same order with the original timestamps. So the cloud will get the data, of course, 1 hour later, but with the original, in the original order, with the original timestamps. So when afterwards you're going to see your graphics or you're going to check your database in the cloud, there will be no missing data.
Perfect. And last question, with vNode, can we read from EtherCAT?
From EtherCAT, you mean?
Yeah. Yes.
Actually, there are many ways about how vNode can read data from real-time or real control devices. The main goal of vNode is not to connect to as many devices or as many protocols as exist, because as vNode can be an OPC UA client, so there will always be an OPC server to connect to something. It can be Matricon, OPC server, or can be any other. For example, if we're talking about EtherCAT, we're talking about Beckhoff OPC server. So the best way to collect the data in vNode from EtherCAT will be using the OPC server from Beckhoff in this case.
Perfect. So that's more or less all the questions are asked in the chat. And if somebody else has some question, they can for sure ask.
Of course, here you have our email address, our phone numbers. So please feel free to download vNode, to ask us about the demo, or if you want, organize with us a meeting and we can explain more about this. No problem. Thank you very much for your time today. You're going to, of course, get an email with the link to the video of the meeting. And and let us know if you have further questions or anything we can help.
Last question, a very quick question. What will be the delay time, Fabian? A very good question from Mr. Rizwan.
The delay is a very tricky question, because the question from my side is they delay on what? Because we have so many components in here. So the main question, actually, what I believe the real the meaning of this question is if I read from my PLC a tag and the timestamp, let's imagine we're collecting a tag coming from a protocol which supports timestamps. For example, a Siemens PLC. So this Siemens PLC is sending us a value with a timestamp 12:45. So vNode will collect the data from the Siemens PLC with the timestamp 12:45, it doesn't matter when we're reading this. It's going to be having the timestamp. In real time, vNode is going to be updating the data inside vNode. Then we have said that vNode, using MQTT in this demo, remember that vNode is updating or uploading the data every 5 seconds. So every 5 seconds, we're going to be publishing the data to the cloud, okay? Because we said 5 seconds. If we say 1 millisecond, would be 1 millisecond. Of course, 1 millisecond is completely out of the reality, but probably, I don't know, 100 milliseconds could be more real, 150, 200 milliseconds, I don't know. Will depend on so many things. For example, the computer where we're running vNode, the network, the internet connection, what we're doing in the cloud. So the delay of all this is, of course, depending on so many things. In this case, we are pushing the data every 5 seconds to the cloud. But the most important part is we are pushing the data to the cloud with the original timestamp. So it doesn't matter if we're moving the data in 1 second later, or 100 milliseconds later, or 5 seconds later, like we are doing right now. The most important part is that this same timestamp, I said 10:45, is going to end up in the cloud. Okay, so we can play with the, because so many objects or so many components are in the middle of this conversation between the control device and the cloud. We're talking about different networks. We're talking about firewalls and routers and different computers and an MQTT and an OPC UA connection or Modbus. And so many components are in the middle that the latency or how long does it take a TCP package to arrive from one side to another is not something we can answer like this. Takes some experience, and our experience says that you can move data from one side to another. 1 second is secure, yes. Less than that will depend on many components. Probably you can try 100, 150 milliseconds. Is something you need to experience with your own network and your own devices, all right?
Perfect. And what is the maximum limit of devices that you can add with, you can configure with one vNode module? For example, if you want to add Modbus PLC that speaks Modbus protocol, what is the limit?
Yeah, actually, the license of the software has no limits. So you can add as many tags as you want. Of course, the limitation is in the hard drive, in the hardware, where you are installing vNode. Of course, if you install vNode in a Raspberry Pi, which is really, really, really low power, you can move, let's say, I don't know, 5 to 10,000 tags. And you can connect, you can make many connections. There is no limit on tags, there is no limit on connections.
How many devices, for example?
In the software. So, for example, we had projects where in very powerful computers, we are connected 800 PLCs, collecting Modbus data from all of them at the same time. Okay, so if you install vNode in a very powerful computer, you can make more connections, you can add more tags. Then if you install vNode in a very, very low power, very small computer, you can move data, I don't know, 5,000 tags, 10,000 tags, and of course, less number of connections. But there is no limit in the software. The limit is in the hardware you're using.
Perfect. So I believe most of the questions are answered very well. But if some of you guys still have some questions, we have our emails here, and we will send you everything by email, and we will be in touch. And let's hope you learned something from this webinar. Thank you so much for your time.
Thank you. See you next time. Bye-bye.
See you next time. Take care. Bye.